why do we need encapsulation, and how exactly encapsulation is going to help you in thinking around the real world low level design problem. This is exactly we are going to solve in this video. So let's quickly get started. First of all, what is encapsulation? Encapsulation definition I have picked from the internet, from Google, and this is what it says. The action of enclosing something in or as if it is in a capsule. So that is what is encapsulation in general. And the same concept applies in the programming world as well. That is, you have a capsule and the things which you want to expose, you expose, and things which you don't want to expose, you don't expose. That's a very high level definition which we are going to see. But let's see in terms of programming. This is how you can represent any object in the world. That is, you will have the name of the object or class, you will have the instance variable, and you will have the methods. If you want to know more about it and see my detailed explanation, I will link the video and you can check out the details on it. Overall, there are 3 sections of any object or class. The instance variables correspond to the state of the object. That is, here the name of the dog and the age of the dog. It can be color, it can be a lot of things which define the state of the object. And the second is the behavior. That is, whenever it wants to make sound, it will make sound. You can call the method make sound and it will do the job. Now, there is one important thing, that these things are interrelated. They are not completely independent of each other. That is, the behavior of any object is dependent upon the state of the object. For example, if you call the method make sound, you might have a logic in the code that if the age is less than 10 for a dog, have a puppy voice. But if the age is less than 1, bark. And there are a lot of logics you can build on top of name and age. And trust me, the actual code would be much more complex. But overall, you can understand that the behavior of an object will depend upon the state of the object. Now, this is the reason that it is important that the state of the object is always correct. They do not become incorrect. For example, we should not allow the age to become -1 or -10, etc. Because it might happen that because of the incorrect state, you get incorrect behavior. So that is what the encapsulation will do. The encapsulation will make sure that the state of the object is always correct. And nobody is able to make the values of the state incorrect. Now let's see how would the regular code look like, whatever we talked in the previous slide. So this is how the regular object or class would look like. The class name is dog. It has 2 instance variable, age and name. They come under the umbrella of state of the object. And this is the behavior, that is the method. That is the bark method. And this method is dependent upon the instance variable, that is the state of the object. So this is the regular object and the regular method. And somebody can call this method bark. And whenever age is between 0 and 1, it will have a puppy voice. Otherwise, it will bark. A regular class. Now in the main method, somebody would instantiate the object, set the value of age, set the name as max, and call the bark. Now this will work fine. When the bark method is called, this bark would get printed and everything is good. However, in the real world, when you are working on big projects, what is going to happen? Would your code look as simple as this? Would the author of code this, that is the class dog, and the author of this main method be same? No. So what is going to happen is that, let's say developer 1 coded for the class name as dog and the developer 2 coded the other method. And now this developer set the value of age as -1. Somehow there are multiple people working in a company or multiple people contributing to the same code, and that person has set the value as -1. Now imagine if the value is -1, what will be the output of the code? The output will be bark because the age was less than -1. So it did not qualify the first condition and it printed the second condition. Now, this person, the developer 1 or someone would get insane. They would reach out to the developer of class name dog and say, hey, why are you printing bark for a dog with the age -1? How is it even possible? Now this person has to investigate. It would not be as easy as, looking into this code. It would be a bit complex. So the thing is, wherever error occurs, we reach out to that class or that developer first. So in this case, since the error would have occurred in this class, that is the dog class, because many people would be complaining that the dog which is not supposed to bark is barking. So what to do? What will happen is that the responsibility of making the state of the class dog always correct lies with the class dog itself. So class dog need to make the state of the object of the class dog correct. The class dog should make sure that nobody from outside, no other developer can make the values incorrect. If the age value is not allowed to be -1, then nobody from outside be even allowed to change it to -1. If the name, let's say some of the not allowed name are there for dog, so nobody from outside should be allowed to set those names. In this way, if this class makes sure that nobody from outside is allowed to change those values, then these values will always be correct. And when the values are always correct, then the behavior will always be correct. So in this way, nobody will reach out to the author of class dog or reach out to this class to see what is going wrong here. So we can actually track the culprit. And this is where the encapsulation comes into picture. This is how the code with encapsulation would look like. If you see here, this is the same class and we have made a few changes. We have made the member variables as private and the methods to set those values as public. This is what the idea of encapsulation is. That is, you protect the state of the object. If you protect the state of the object, you will protect the behavior of the object as well. So you have made these values as private and then you have made the values of getters and setters. That is, how do you get those values and set the values as public. Now outsiders cannot call these age and name directly the way they were doing it earlier. That is, dog.name, dog.age directly. They have to call the set and get method. And when an outsider or random developer from some other team or the other class, when that person tries to set age as -1, they will get error here. Now, since they will get error here, nobody is going to chase the developer of this class. So state will always be sane and the bark method will work the way it is supposed to work. Some might say that you can have the validation of age less than 0 at the beginning of all the methods. So let's say bark method is there, maybe run method is there. So somebody can argue that just have validation at the beginning of all those methods. But that makes things complex because now you have to make sure that these validations are there all the time in all the methods. And it always gets hard. What if somebody misses to have those validations at the method level? So what you do, you nip such errors at the bud. You don't even allow the incorrect values to be set. Since you don't allow those incorrect values to be set, so you don't have to worry at the implementation or the time when you call the methods. So this is the place where you would actually call the methods. You don't have to worry whether the state of the object is correct or not, because here you have protected the state of the object. So this is the overall idea of encapsulation, that you make the member variables private and then you expose the values of those member variables using the public methods so that your state gets preserved. This brings us to the summary of the video. That is, when you use encapsulation, two main problems get solved. The first is that the correctness of the member variables are always correct. Nobody can set insane values of the member variables, because now you have private member variables and the public getters and setters. So if there are multiple people working in a company, or there are multiple people working together, they will have the clear responsibility around making the values correct for their own classes. That is the first thing. And the second is that having the validation in the member variable will make sure that you do not need to have the validation on each method. So whenever you call the park method, you don't have to care about the value which is there for the age, because the value will always be correct. The getters and setters will make sure that the values are correct. So you do not have to repeat the same validation in all the methods. You just have the validation in the state variables and you are good to go. So this brings to the conclusion of the video. I hope you like this video. I will post more such videos in the coming week. Till the next time, bye.